This is the introduction to section 8.2, part 1, and what you're going to need to do to start here is find an open blank page in your notes. I've got one more little thing that we need to talk about with square roots and rationalizing and simplifying in terms of radicals. So first thing we're going to talk about here is we're going to talk about rationalizing the denominator. And what that means is, rationalizing the denominator is that you're not allowed to have a square root in the denominator of a fraction. So in order to do that, we've got to get that square root out of the bottom. So how are we going to get that square root out of the bottom of the fraction? Well, we're going to multiply the fraction by the denominator over the denominator in order to simplify the fraction. So as you're looking here at this first example, we have 3 over the square root of 3. Now again, you cannot have this square root in the denominator. So what we're going to do is we're going to multiply by the denominator itself, the square root of 3 over the square root of 3. Well, as you look at the square root of 3 over the square root of 3, this number right here is really the number 1, just written in a different manner. So I'm not changing it. I'm not changing the number. Okay, but multiplying by 1 doesn't change anything. What we're doing is we're changing what it looks like. Okay, changing what it looks like. So as we go through here, and I multiply by 3 times the square root of 3, on the top, I would get 3 times the square root of 3 over the square root of 9. Well, because the square root of 3 times the square root of 3 is the square root of 9. Now I can simplify even more. I've got 3 square root of 3 over the square root of 9 is 3. Okay, and now I no longer have a root in the denominator. Now, one thing that I also have to check to see is, can I simplify this fraction once I get done? Well, here's the deal. If there's a number outside the root on the top and on the bottom, if there's something that will go into both of them, they can simplify. But the root cannot be simplified with just a regular number. So, as you notice, these 3's are exactly the same. We're going to cross those 3's out. They cancel each other, and I'm left with the square root of 3. Remember, you treat the square root symbol like jail. Nothing comes in, nothing goes out. Okay, you can't get out of jail, and you can't come in jail unless you do something wrong. Okay, so let's take a look at example number 2 now. This one we have 8 over the square root of 2. So again, to get rid of the square root in the denominator, I'm going to multiply by the square root of 2 over the square root of 2. This becomes 8 times the square root of 2 over square root of 2 times square root of 2 is square root 4. Now, you don't necessarily have to show this step every time. I'm just getting you to understand on the bottom, when you take the square root of 2 times square root of 2, you get square root of 4. And then that's going to simplify for you. So now I get 8 times the square root of 2 over the square root of 4 is 2. And as I look at my numbers outside of the root, 8 divided by 2 will simplify. That'll simplify into 4 over 1, so it's really 4 times the square root of 2. This guy will cancel out. This guy becomes a 4. Okay, so rationalizing the denominator, you're going to use that in your application of what we're going to talk about here in section 8.2. Okay, section 8.2 talks about special right triangles. Now, we've talked about right triangles. We've talked about the Pythagorean theorem, how to find sides of right triangles. There are 2 types of triangles that are considered special right triangles. Okay, 2 types of triangles. The 2 types of triangles are the 45-45-90 triangle and the 30-60-90 triangle. These are the angles of the triangle. Okay, it has a 45-degree angle, a 45-degree angle, and a 90-degree angle in that triangle. And the other triangle has a 30-degree angle, a 60-degree angle, and a 90-degree angle. Okay, so let's first talk about the 45-45-90 triangle. Okay, so as we talk about the 45-45-90 triangle, both legs are congruent, and the length of the hypotenuse is square root of 2 times the length of the leg. Now, let's talk about this kind of triangle first. 45-45-90. You'll notice that these base angles are exactly the same, which means that the sides opposite them are the same. So in other words, this is an isosceles triangle. It's an isosceles right triangle, which happens to be what we call a 45-45-90 triangle. So if we don't know the legs, we make them X, or in this case, they make them S. And what they're saying here is if I know that the sides of the right triangle, I can figure out the hypotenuse. Remember, in this case, a squared plus b squared equals c squared. Well, if I take the two legs, that's s squared plus s squared, and let's say I don't know the hypotenuse. Let's say I don't know this right now. I don't know that that's the s times the square root of 2. How would I find that? Well, I would simplify and solve this equation. This happens to be 2 s squareds is equal to c squared. And now to find c squared, I got to take the square root of each side. And this becomes c equals s squared with the square root, that comes out front, and the square root of 2 stays inside. So that's how they come up with s times the square root of 2 for the hypotenuse. Okay? So you know, in this case, the formula that's going to be important for you to remember is this formula, that the hypotenuse is equal to the square root of 2 times the leg. Or, if you want to know the leg is going to be equal to the hypotenuse divided by the square root of 2. Okay? So, these two formulas are going to be important as you're going through some examples. Now, let's take a look at the example down below this. It says, find the length of the hypotenuse. What is the value of each variable? Okay, so, in this case, they're not giving you the hypotenuse in either one of these. It's not always going to necessarily be that way. So, the formula, again, as you look at this, hypotenuse is equal to the square root of 2 times the leg. In this case, we don't know the hypotenuse. That's h is equal to the square root of 2 times the leg, in this case, is 9. So in other words, the hypotenuse is equal to 9 times the square root of 2. Okay? All you're simply doing is substituting in what you know into the formula. Okay? So let's take a look at this next one. Again, the hypotenuse is equal to the square root of 2 times the leg. Well, in this case, the hypotenuse is x. Square root of 2 times the leg is 2 times the square root of 2. So I've got square root of 2 times 2 square root of 2. This becomes 2 times the square root of 4. The square root of 4 is 2, so this is really 2 times 2, which in this case, x, the hypotenuse, is going to equal 4. Okay? So the important part is that you're using the formula, determining is it a 45, 45, 90 triangle. If it is, I've got these two formulas, whether I need the leg or whether I need the hypotenuse. Okay, let's take a look here at the other set of triangles. We've got 30, 60, 90. Now this one's a little bit more difficult because it's a little bit different. It's not an isosceles triangle anymore. You'll notice a 30-degree angle, you got a 60-degree angle, and you got a 90-degree angle. Okay? So, as you look at the triangle here, we know that the short leg is always going to be, in this case, s or x. If we know the short leg, we can figure out the hypotenuse and the long leg. Okay? Remember, in the 30, 60 degree, 90 triangle, how do you determine what the long leg is? The long leg is always opposite the 60 degree angle. The short leg is always opposite the 30 degree angle. And the hypotenuse is always opposite of the right angle. Okay? So, as you look at these formulas now, we know that the hypotenuse is 2 times the shorter leg, and we know that the longer leg is the square root of 3 times the shorter leg. These two formulas here you're going to use. Okay? So let's take a look at the example below. Using the length of one side, what is the value of d to the simplest radical form? So I'm going to have to simplify some radicals here. All right, so I've got two variables. I've got f and I've got d that I need to find. So again, I'm going to write down my formulas. Hypotenuse. This is a 30, 60, 90 triangle. Is 2 times the shorter leg. So as I look at this, the hypotenuse in this case is f. 2 times the shorter leg is opposite of the 30-degree angle, which is D. Now, there's a problem with this formula. I can't solve it because I've got two variables. So let's take a look at the other formula. The long leg is equal to the square root of 3 times the short leg. Well, the long leg is opposite of the 60-degree angle. That's 5. Square root of 3 times the short leg, which is D. Now, I can solve this equation. Okay? So in order to solve this equation, I'm going to divide by the square root of 3 on each side. And D is going to equal 5 over the square root of 3. Well, if you remember at the beginning of the video, we said we can't have a radical in the denominator, so I'm going to multiply by square root 3 over square root 3. And that's going to give me D, 5 square root 3 over the square root of 9. Well, the square root of 9 is 3, so this is 5 square root 3 over 3. That's how much D is. Nothing goes into 5 and 3. Okay? So now what I'm going to do is I'm going to plug this in to this equation up here now to find out what F is. Okay? I know they're asking you for D, but we're also going to look at F as well. Okay? So if I plug that in, F is equal to 2 times 5 square root 3 over 3. Well, that just simply means that F is going to be 10 times the square root of 3 over 3. Or you're taking 2 over 1 times that. Okay? All right, so this concludes section 8.2 part 1. Don't forget to complete your WSQ and really pay attention to those formulas for the 45, 45, 90 and 30, 60, 90.